Hello my dear students. In this video you learn how to perform operation with functions. But first let us understand this concept. It is very common to have functions that are defined in terms of the sums or the differences, the products, or even the quotients of some other functions. Example, suppose we have a function h, and that h is defined h of x equals to x raised to the power of 3 plus 2 all over x square, such that x is not equals to 0. Suppose this function is a function h. Let us see what we can do. If we have other functions f and g, and that function f and g are defined by the formula, and the function f is defined by the formula f of x equals to x raised to the power of 3, and the function g is defined by the formula g of x equals to 2 over x square, such that x is not equals to 0. These are two individual functions f and g. And looking at the function h, when you look at the function h, which is h of x equals to x raised to 3 plus 2 all over x square, and looking at these two individual functions f and g, we can now discover that the function h of x, which is x raised to 3 plus 2 all over x square, will now be equals to f of x plus g of x. The f of x is simply x raised to 3, and the g of x is simply 2 all over x square. Then we may now consider the function h of x as sum of the two individual functions f and g. So you can now see the function h is the something as sum of two other functions f and g. So we can have a function that can be expressed as difference of two other functions. We can also have a function that can be re-expressed as product of two other functions, and so on. Next we'll add is some definitions about operation with functions. There are things that we're supposed to know whenever we are performing operation with functions. So let f and g be two functions. If f and g are two functions, then number one definition that we must know, the f plus g, meaning the new function which serves as sum of two other functions, that is f plus g. This is the sum of f and g and is defined by f plus g of x is the something as f of x plus g of x. So to get the sum of two functions f and g, what we simply do in the formula for f of x and in the formula g of x, you add them together. That will give you the new function that serves as sum of f and g. Definition number two, it says f minus g, that is the difference of f and g, that is defined by f minus g of x is equals to the f of x minus the g of x. And the definition number three, that is fg, f times g, that is the product of f and g. That thing is defined by f of g of x to be equals to f of x multiplied by g of x. And finally number four, the f divided by g, meaning the quotient of f and g. This is defined by f over g of x to be equals to f of x divided by g of x. So this is what you simply do to perform operations on functions. You will be given two individual functions f and g and asked to find either their sum or their difference, their quotient or their product. Simply make use of these definitions to find the answers. We'll take examples. Another thing we learn next is the domains of those functions. That is, domains of sum of two functions, domains of difference of two functions, domains of a product of two functions, and so on. What will be their domains? So if f and g are two functions, and those two functions have domain d and s respectively, if that thing happens, then number one, the domain of sum of two functions, and the domain of difference of two functions, and the domain of product of two functions, that domain is, now we have a domain of the two functions equals to the domain of the sum of the two functions to be equals to domains of the difference of two functions. It's the same thing as also domain of the product of two functions, and those domains is nothing but the domain of f intersect domain of g. When you form the intersection of those domains, the set you formed is now the domain of the sum of two functions, the product of two functions, and the difference of two functions. And when we substitute now, because up there we have said the domain of f is d and the domain of g is s, then we can now rewrite this to be equals to d intersect s. D is a set that represents the domain of f, and s is a set that represents the domain of g. But the domain of f over g, meaning the quotient of the two functions, their domain, will now be equals to domain of f intersect domain of g minus a set with elements x such that g of x equals to 0. So what we simply do, we form the intersection of the two domains, that is the domain of f and the domain of g. Then we try to subtract those elements in the intersection, and those elements will now be those elements that will give g of x equals to 0. Because when g of x equals to 0, the function g of x, remember, will now be at the denominator level. So those values of x that gives g of x equals to 0, we have to remove them from the intersection. Then we can now rewrite this to be equals to d intersect s minus a set with elements x such that g of x equals to 0. This is what we now do to get the domain of the quotient of two functions. We'll take examples. Example 1. Let the function f, defined by the formula f of x equals to x plus 1 all over 2x minus 1, and another function g defined by the formula g of x equals to x minus 1 all over x. If we have these two functions, then the question asked here is to find the sum, the difference, and the products of f and g. When we now do that, the question be asked is saying that we state the domains of each. So solution to this problem, let us start with the question A. And that question A, let us start by sum of the two functions. So f plus g, that is, I'm attempting to get the sum of the two functions. F plus g is nothing but, remember in the definition, it says f plus g would now be equals to f of x plus g of x. F of x plus g of x will now give me the sum of two functions. But my f of x is nothing but x plus 1 all over 2x minus 1. And my g of x is nothing but x minus 1 all over x. So I will now substitute. I will get the sum of two functions to be equals to x plus 1 all over 2x minus 1 plus x minus 1 all over x. This will now be the sum of two functions. I will move ahead to get the difference of two functions, that is f minus g. The f minus g, according to the definition, it says is nothing but f of x minus g of x. My f of x is nothing but x plus 1 all over 2x minus 1. I substitute it. And my g of x is nothing but x minus 1 all over x. Therefore, the difference of the two functions, f minus g, will now be equals to x plus 1 over 2x minus 1 minus x minus 1 all over x. This is the difference of the two functions. Finally, I will get the product of two functions, fg. Fg is now equals to, according to the definition, it says it's equals to f of x multiplied by g of x, and I have f of x as x plus 1 all over 2x minus 1. My g of x is nothing but x minus 1 all over x, so my product of two functions fg will now be equals to x plus 1 all over 2x minus 1 multiplied by x minus 1 all over x. This is the product of those two functions f and g. I can now move and answer question number B. Question number B says we are to find the domain of each. That is the domain of the sum of the two functions, the domain of the difference of the two functions, and the domain of the product of the two functions. So let us see the domain of the sum of two functions first. This domain of sum of two functions is question mark, so maybe I have to do something before I can get it. Remember, domain of sum of two functions is equals to the domain of f intersect domain of g. So what I will do first is to get the domain of f and the domain of g. The domain of f, what I will do, I will look at the definition of the function f, and that function has a fraction. It's an algebraic fraction, so I'll look at my denominator. Those values of x that when substituted at the denominator level, the denominator changes to 0. I'll exclude those values from the set of real numbers. That will be my domain of f. Remember, in our previous lesson we have discussed domain, codomain, and range. So if you have problem with this, it's good you check that video. So domain of f will now be equals to, I will now try to exclude the value of x that makes the denominator of f of x 0. So that value of x that will make my denominator 0, I will solve 2x minus 1 equals to 0. If I solve it, I will arrive at x equals to 1 over 2. So the value of x equals to 1 over 2 will make my denominator 0 in the f of x. So my domain of f will now be a set with x, such that x is from minus infinity to infinity, but x should not be equals to 1 over 2. So all those real numbers, all the real numbers that you know with the exception of 1 over 2, serve elements in the domain. So that is my domain of f. I'll also get the domain of g. To get the domain of g, I'll look at the formula for the definition of g, of the function g. That function g says is x minus 1 all over x. As it is algebraic fraction, I will consider the denominator. What value of x makes my denominator 0? It is x there at the denominator level. So the value 0 for x makes your denominator 0. So your domain also for g will now be equals to all those real numbers with the exception of 0. Will now serve as the elements in your domain of g. So domain of g will now contain x, such that x is from minus infinity to infinity, but x should not be 0. So I have now domain of f and the domain of g. So what I will now do to find the domain of the sum of two functions, according to the definition, is the intersection of the domain of two functions. So I will now intersect the domain of f and the domain of g. The domain of f is from minus infinity to infinity with the exception of 1 over 2. And the domain of g is from minus infinity to infinity with the exception of 0. Therefore, the intersection of these two sets will be nothing but from minus infinity to infinity, but with the exception of 0 and 1 over 2. So therefore, domain of sum of two functions will now be equals to a set containing x, such that x is from minus infinity to infinity, but we subtract those elements 0 and 1 over 2. And this domain of sum of two functions is also the same as domain of the difference of two functions, and is also the same as the domain of the product of two functions. Another example, it says let the function f, and that function f is defined by the formula f of x equals to x raised to the power of 3 plus 3x. And another function g defined by the formula g of x equals to 3x squared plus 1. If we have those two functions, the question asked here is to find the quotient of the two functions, that is f over g, and we are to find its domain. And this is another question that we needed to solve. Solution to this problem: remember, according to the definition, the quotient of two functions f over g is nothing but the f of x over the g of x. But my f of x is given by the formula there, you can see it, and I have g of x, the formula, you can see it also. So when I substituted those formulas for f of x and g of x, so I will now have the quotient of the two functions as x raised to 3 plus 3x all over 3x squared plus 1. This gives me the quotient of the two functions. But the question asks also to find the domain of those quotient. Domain of the quotient of two functions, question mark. What I will do, I will have to get the domain of f and the domain of g. So domain of f, I will now look at the formula for the function f. That formula is x raised to 3 plus 3x. I will try to think which value of x in the real number that will not give another real number there. So all the real numbers that substituted for x, the answer will also be another real number. So the domain of f will now be a set containing x such that x is from minus infinity to infinity, meaning all the real numbers will give another real number when substituted in the formula f of x. I will go ahead to get the domain of g. I will look at the formula for g, the function g of x equals to 3x squared plus 1. So there I will look at the formula. That formula also, if I substitute any value of x, the answer will still be another real number. So which means the domain of g will also be a set from a set of all real numbers. So domain of g will now be a set containing x such that x is from minus infinity to infinity. So I can now get the domain of the quotient of the two functions. The domain of the quotient of the two functions, from the definition it says, is the something as the domain of f intersect domain of g. Then we have to subtract some elements meaning we have to subtract this set, and this set contains x such that g of x equals to 0. So we have to subtract from this intersection those elements that when substituted in the formula g of x, the answer will be 0. So I have to subtract them. So to get those values of x that g of x makes it to 0, I have to solve the formula g of x equals to 0. So solving g of x equals to 3x squared plus 1 equals to 0, solving this quadratic equation, I will have x as a square root of minus 1 over 3. Square root of negative number, remember, is not a real number. It's not in the real plane. So this is not in R. It's not even a real number. Which means any real number, when substituted in g of x will not be 0. Because the value that makes g of x equals to 0 is not a real number. So therefore, we can now write our domain of the quotient of the two functions to now be equals to the set with x, such that x is from minus infinity to infinity. This is the end of this lesson. Let us now revise some of the key things that you have learned in this lesson. You have learned in this lesson that some functions can be defined in terms of sums, products, differences, or even quotients of other functions. You have also learned in this lesson that if f and g are two functions, then the sum of functions f plus g of x is nothing but f of x plus g of x. You have also learned that the difference of two functions is nothing but the f of x minus the g of x. You have also learned that the product of two functions is nothing but the f of x multiplied by g of x. You have learned also that the quotient of two functions f and g is nothing but the f of x divided by g of x. You have also learned in this lesson that if f and g are two functions, then the domain of sum of two functions is the same thing as the domain of the difference of two functions, the same thing as the domain of the product of two functions, and is the same as the domain of f intersect domain of g. You have also learned in this lesson that if f and g are two functions, then the domain of quotient of two functions f and g is nothing but the domain of f intersect the domain of g minus the elements that makes g of x equals to 0.